Okay, so today we're going to work on Module 3 questions, and you'll see that in Module 3, the questions are pretty much just plug and chug and maybe a little bit of rearrangement of the equations that I have here on the side of the screen. So let's start off with a couple of simple ones. A flashlight bulb carries a current of 0.12 amps. So remember, we do the goal method, gather. So we're going to go through the problem and pull out every number and see what it is. So we've got a current of 0.12 amps. So current is I, is 0.12 amps for 65 seconds. So 65 seconds, that's a time. So let's say time is 65 seconds. How much charge flows through the bulb in this time? So charge is Q. So we're trying to find Q. All right, so we've gathered. Next thing we need to do is organize. So figure out what equation we need. So we want an equation that's got Q in it, and if we look at our equations over here on the right, you can see there's only one equation that's got Q in it. That's that first equation there. So current I is equal to delta Q over delta T. So next thing to do is just do the algebra. A is for algebra. All right, so let's do, we want to find Q. So delta Q, which means the amount of charge in a certain time, is just going to be I times delta T. And now we just plug and chug. So I is 0.12 amps. T is 65 seconds. Throw that in our calculator, we get 7.8. Unit for charge is coulombs. So delta Q, the amount of charge through the resistor is, through the bulb, is 7.8 coulombs. Okay, so that one was pretty easy. Let's go on to the next one. So next one, we have a silver wire. Is 4.5 meters long. So again, let's write down everything we know. So the length is 4.5 meters and 0.45 millimeters in diameter. So let's use symbol D, is 0.45 millimeters. And remember, we want everything in SI units. So let's go straight ahead, turn that into meters. So that's going to be 0.45 over 1,000, which is 4.5 times 10 to the minus 4 meters in length. Okay, so in diameter. What's its resistance? So we're asking R equals question mark. That's what we're trying to find. And we're told that the resistivity of Ag is a chemical symbol for silver. The resistivity is 1.59 times 10 to the minus 8 ohm meters. So we've got the length, the diameter, and the resistivity. We want to find the resistance. So we want an equation with R. And if we go up and we look at our equations, there's a lot of equations here that have an R in it. Okay, so what are we given? Well, we're given the length and the resistivity. So if I look at the equations, you can see I want to use this equation here. So I've got the resistivity, I've got the length. I need to have A. What's A? A is the area. So the area, remember our wire has a circular cross section. Has an area A and a length of L. Okay, so our A is going to be equal to pi times the radius squared. Okay, so let's pull this up a little bit. So area is pi r squared. So it's going to be pi, and the radius is the diameter over 2, right? So area is going to be pi times the diameter, 4.5 times 10 to the minus 4, divided by 2 squared. We're going to get a really tiny number, 1.59 times 10 to the minus 7 meters squared. All right, so now we've got the length, the area, the resistivity. Now it's just plug and chug into the equation that R equals rho L over A. So the resistivity, 1.59 times 10 to the minus 8, times the length, 4.5 meters, divide by the area, which is 1.59 times 10 to the minus 7 meters squared. And if you plug all that into your calculator, you get 0.45, and the units for resistance is ohm, so capital Greek omega. So remember, when you're doing these kind of calculations, when you've got something that's got a times 10 to the in the denominator, when you put into your calculator, you need to make sure that you do divided by, open bracket, 1.59 times 10 to the minus 7, close brackets. Or what your calculator will do if you don't do that is it's going to multiply by times 10 to the minus 7 instead of dividing by times 10 to the minus 7, and you'll get the wrong answer. Another thing to do is if your calculator has a button that has EE, if you do 1.59 EE minus 7, then your calculator automatically ties those things together and it never messes up. So if you have a question about that, make sure you ask me in class or during my office hours, and we can take a look at your calculator and I can show you how to do that.